Morning everyone, myself Alex Babu Joseph. I am here to take a seminar on the topic MicroLED Display and guided by Assistant Professor Srish PSR. And we can move to the table of content page. And first one is introduction, and second one is overview. Third one is about MicroLED. Fourth one is working of MicroLED. Fifth one is manufacture, and sixth one is advantages. Seventh one's applications. Eighth one is challenges and future outlooks. Ten conclusion, and the last one is references. Then we can move to the introduction page. All my friends, the micro LED is the future of display technology. Is almost uh, here. So in this seminar, I am going to explain you exactly why micro LEDs are considered as the true successors to the OLEDs and the future of display technologies. Before I explain micro LED, it is important to give you about the display technology. Then only you understand the importance of the micro LED compared to the other display technology. Then we can move to the overview of the display technologies. Uh, then this is overview of display technologies. In here, I am mainly explained six display technologies, and first one is cathode ray tubes, called as CRTs. Second one is liquid crystal displays, LCD display, and third one is plasma displays. Fourth one light emitting diode displays, LED display, and organic light emitting diode, OLED displays, and the last one is the micro LED displays. Then we can move to the CRT displays. CRT displays is mainly used in 1990, before 1990s. It is like a box type TV. We use the CRT displays, and the CRTs were the dominant display technology for many years, and they use a beam of electrons to illuminate the phosphorus coated screen. Then we can move to the LCD display, and LCD display replaced the CRT display in late 1990s, and they are much thinner, lighter, and more energy efficient than CRTs. And the LCD displays is also available in present life also, and the LCD display is now available at, and they are integrated with the contour dots. Uh, Next, their displays, plasma displays. Plasma displays offered excellent picture quality with wide viewing angles, and the plasma displays were popular for a short time in the early 2000s. And because a very short time period, the plasma displays is available due to so many issues, they discontinued the products. And the fourth one is LED displays. LED displays uses LEDs as individual pixels, and LED displays are now widely used in TV, smartphones, and other devices. And we can compare the LED displays with the LCD displays, but the purpose of the LED displays and LCD displays are same, because in there is a liquid crystal is in between the backlight, and the pixels are arranged in the LCD display. But in the case of LED displays, instead of liquid crystal, they use the LED. So the image quality will be more clear when we compare to the LCD display. Then we can move to the fifth one is OLED display. OLED displays are self-emissive, meaning that each pixel emits its own light. They offer perfect blacks, infinite contrast ratio, and fast response time. In OLED displays, it means it does not need a backlight support, and each pixel will create its own lights. So there will show the perfect blacks and much uh, image quality than other displays. Then we can move to our topic, micro LED display. Micro LED displays are the latest generation of display technologies. Micro LED display offer all the advantages of OLED display, as well as high brightness, low power consumption, and long lifespan. And the micro LED displays are still in their early stages of development, but they have the potential to revolutionize the display industries. Then we can move to the timeline of micro LED. In 1990 was the idea about the micro LED was started, and in 2000s the micro LED invented in Texas University, and in 2010 the manufacturers were aggressively developing the micro LED display through integration and R&D. 2000 solely launched the first micro LED TV in 2023. 2016, the Sony unveiled its large area outdoor micro LED, and 2020, Apple invested on micro LED display. And 2023, the Samsung launched a micro LED with a 240 Hz refresh rates. And in here, in between 2000 and 2010, the micro LED displays mainly focused on small scale industries like projectors, etc. In 2010, they were focusing on the large scale industries like smartphones, TVs, etc. Then about the micro LED. I already said the microLED is also known as it's a self-emissive display technology that uses microscopic LEDs as individual pixels, and each pixel in a microLED display is a microscopic LED and that emits its own lights. And the micro LEDs are typically smaller than 100 micrometers in size. Uh, they are made up of inorganic semiconductor materials such as gallium nitride or Indian gallium nitride. Uh, the micro LED displays are made up by transferring micro LEDs onto a substrate, and the micro LEDs are arranged in a grid with each micro LED representing a pixel. Micro technology is still under development, but it has a potential to revolutionize display technology. And here are some of the key features of the micro LED display. First one is a self-emissive. I already said the micro LED emits their own light, so they do not require a backlight. This allows micro LED displays to achieve the perfect blacks. Because there is no need of a backlight support is needed. So I already said the each pixels provide its own light, so it will shows a perfect blacks and image quality and infinite contrast ratio. The combination of perfect blacks and the high brightness creates an infinite contrast ratio. So the contrast ratio is also explained in here. Then the fast response times. The micro LED have very fast response time like 0.2 nanoseconds, and this makes them ideal for high motion applications such as gaming and sports viewing. Then we can move to the next slides, and the high brightness. Micro LED displays can emit very bright light and reach up to 4000 nits of peak brightness, and this makes them suitable for outdoor applications. And the next point was low power consumption. The micro LEDs are very energy efficient. This makes them the ideal for battery power devices. Their average power consumption of an 55-inch micro LEDs can be below 5 watt. And the next point was long lifespan. And the lifespan of the micro LED is around 100,000 hours continuous, and this is made up of mainly inorganic materials. Uh, And next one is flexible and transparent. Micro LED displays can be made flexible and transparent. This makes them suitable for a wide range of applications. Then we can move to the working of the micro LED display. Uh, Micro LED displays are made by transferring microscopic LEDs on the substrate, and the LEDs are arranged with each LED representing a pixel. And the working of micro LED is mainly divided into four steps. First one is electron transport. Second one is radiative recombination. Third one is light extraction. Fourth one is image formation. Then we can move to the first point, electron transport. In the case of electron transport, the microLED is composed of mainly two semiconductor layers, N-type and P-type. N-type is richer in electrons and P-type is richer in holes. Voltage is applied across the microLED. Then the electrons in the N-type layer is attracted to the positive electrons, and the holes in the P-type layers are attracted to the negative electrons. The flow of electrons and the holes are in the current in the micro electric current in the micro LED. Then we can move to the next step is radiative recombination. In the case of radiative recombination, as the electrons flows through the micro LED, they collide with the holes. Then when an electron and a hole collide, they recombine, releasing energy in the form of a photon. Determine the wavelength of the light emitted. The wavelength is mainly depends on the energy band gap of semiconductor, and the energy band gap determines the energy differences between the valence band and the conduction band. Then we can move to the next step is light extraction. In the case of light extraction, The photon emitted by the micro LED need to be extracted from the device so that they can be seen. And this is done using a variety of technique. One common technique we use is the transport electrodes, and in transport electrodes it allows the light to pass through them. And another technique is micro lenses, and the micro lenses are mainly focused on the light emitted by the micro LED, making it brighter. And the last one is image formation. In the image formation, the micro LEDs are arranged in grid on display substrate, and the micro brightness of each pixel is controlled by the amount of current flowing through the corresponding micro LEDs. Then we can move to the manufacturing of micro LED display. And the first one is substrate preparation. In the case of subtraction, first one is the selection of substrate material. Mm, the choices of the substrate material is essential and depends on the factor such as cost, compatibility with the epitaxial growth process. And the substrate materials are sapphire, silicon, carbide, silicon, etc. But the sapphire is popular choice due to its then in that then the substrate preparation, and one of these is cleaning process. Substrate must be thoroughly cleaned to remove any contaminants and impurities that could affect the epitaxial growth and the performance of the micro LED. And the different types of cleaning process are solvent, ultrasonic, and chemical. Then one of the next steps of the substrate preparation is surface preparation. After cleaning the process, the substrate surface may undergo surface treatments to enhance its quality and suitability for epitaxial growth treatment include chemical mechanical polishing. Then we can move to the next step is epitaxial growth. Uh, in the case of epitaxial growth, epitaxial growth is a crystal growth process in which a thin layer of crystalline material is deposited on a crystalline substrate in such a way that newly grown layer adopts the crystal of very fixed structure. So there are mainly used three methods: chemical vapor deposition, molecular beam epitaxy, metal organic chemical vapor deposition. And the chemical vapor deposition CVD, which called the process that involves the reaction of a volatile uh, process which inject into chamber, and the molecular beam epitaxy is a thin film deposited on the crystalline surface. And the third one is metal organic chemical vapor deposition, and it reacts with the gases and combine the elevated temperature in the reactor to chemical in. And then you think why we use the crystalline material in the micro LED. So, because the crystalline material is a substance in which the atoms, ions, or molecules are arranged in highly ordered. In micro LED, the epitaxial growth of crystalline semiconductor layers is a fundamental step in the manufacturing process. So, these epitaxial layers form the active region of the individual micro LED pixel, allowing them to emit light efficiently. And the use of crystalline materials in the micro LED technology ensures that these display technologies provide high quality images, long term reliability. And in micro LED displays, each individual pixel consists of a semiconductor material and typically a gallium nitride, and which gallium nitride, which emits the light when properly energized. This property is cruciated the display's ability to produce light and form images. And then and then I already said that gallium nitride are we are using the semiconductor material. Then why we use when then we have to think why we use the gallium nitride material. And the mainly three reasons are there because of the wide band gap, which means that it handles the high electric voltages and operates at a high temperature without breaking down. Second one is high electron mobility, exhibits high electron mobility and allowing for efficient electron transport within the semiconductor. Then the second point is high electron. So third point was efficient light emission. And the gallium nitride is a direct band gap semiconductor and make it highly efficient at emitting light when an electric current is applied. And this property is essential for micro LED displays, where the efficient conversion of electric energy in the light is crucial for the brightness and the energy efficiency. Then we can move to the next is wafer fabrication. In the case of wafer fabrication, it is referred to as the wafer manufacturing, and it is a critical process in the semiconductor industries, and it involves the production of semiconductor wafer and which are thin. And the wafer fabrication process is done by a tool called UV excimer laser, and individually it's micrometric in size. So each LED should place it in a precise place. So we use a wafer fabrication process, and the wafer fabrication is very important process, and it helps to create a robust and reliable micro LEDs. Then and then the testing and sorting. The testing and sorting, when after wafer fabrication process, I already said the LED should place it in the precise places. So the pixel want to check if the is defected or it's working. So we uses testing and sorting methods. Then we can move to the next important step is called mass transfer. In this, the transferred into a final display substrate. Methods include pick and place using robotic system or stamping techniques. Accurate alignment during transfer is crucial for high resolution displays. After this testing and sorting methods, and we move these all displays to another a final display. That was very crucial and the micro crucial and essential step of the micro LED display. And the panel assembly, honestly, the ones the micro LED has transferred into display substrate. The additional layers are such as transparent cover layer and the backplane electronics. Then testing and inspection. Then the assembled micro LED panels undergo rigorous testing to ensure the proper functionality. And encapsulation is like a barrier of this process to protect the micro LEDs from environmental factors like moisture and oxygen, and the display panel is also encapsulated. Then the quality control packaging. Final quality control checks ensures the micro LED displays and meet specifications, and the displays are packaged for distribution and integration into consumer products. And then last one is the integration into products. After this all steps, the micro LED displays are integrated into various consumer electronics products like TVs, monitors, smartphones, etc. Okay. Then we can move to the advantages of micro LED displays. Um, First one is perfect blacks because perfect blacks because each pixel is creating its own light, so the color should be a perfect blacks and infinite contrast ratio. The response time, fast response is 0.2 nanoseconds, high brightness 4000 nits, long lifespans, a continuous work of 100,000, and flexible and transparent, low power consumption. I already explained it, the key features of the micro LED displays. Then we can move to the applications of the micro LED displays. First one is wearable. Micro LED displays can be used in wearable devices such as smartwatches and fitness trackers to provide more compact and energy efficient display. Then the second one is automotive display. Micro LED displays can be used in automated displays such as head-up displays and instrument clusters. Third one is smartphones. The micro LED displays can be used in smartphones to provide a brighter or more vibrant displays with better contrast ratios. And fourth one is the TVs. Micro LED displays can be used in TVs to provide a more immersive viewing experience with better picture quality and digital signature. Micro LED displays can be used in a digital signature application to provide more eye-catching and engaging displays. Digital signature, which means we are representing and explaining any portion to the audience, so we use a digital signature. Uh, then gaming mode it is. In micro LED display, I already explained it was a very fast response time. So the response time give a great experience to the gamers. Then the medical displays. Micro LED display can be used in medical displays such as surgical microscopes, and imaging systems to provide more accurate and detailed view of images. And the challenges, the first one is a mass production. I already explained that the working manufacturing of the micro LED displays, the mass productions. The micro LEDs are still in the early stage of development, and mass production is still a challenge. The cost of micro LED displays is high, and the L rate is low, and the precision alignment. Micro LEDs are very small, and they need to be aligned very precisely in order to create a high quality display. And this is a challenging task, and it can lead to defects in the display. And the one is color uniformity. Color uniformity is a variability is compounded because each micro LED is typically a monochromatic subpixels and suffer from which means that the colors of different pixels may not be perfectly matched. Fourth one's the defects, and the micro LEDs can suffer from defects such as dead pixels and bright spots. These defects can be caused by a variety of factors such as manufacturing errors and impurities in materials. Then there's the challenges of the micro LED displays, and then the future outlooks. First one is the growing demand for high quality displays, and the consumers are demanding higher quality displays with a better picture quality, contrast ratio, and brightness, and the increasing adoption of micro LED displays in smartphones and TVs. The micro LED displays are expected to be adopted in smartphones and TVs in the coming years. Development of new micro LED manufacturing technologies. The development of new micro LED manufacturing technology is expected to reduce the cost of micro LED displays and make them more affordable. uh, Growing demand for medical displays. The micro LED displays are also expected to be adopted in the medical displays such as surgical microscopes and imaging systems, and the growing demand for wearable displays and the increasing demand for automotive displays. And this is a display volume forecast of the micro LED displays and in smartphone, tablets, smartwatches, and in 2025 it was increasing much large millions of 300 more than 300 millions of units. And these were the conclusion. As we know, the micro LED is the future of the display technologies, offers a number of advantages over current mainstream display technologies. They are brighter, have better contrast ratios and more energy efficient, have longer lifespans, and can be made flexible and transparent. However, the micro LEDs are still in the early stages of development, and there are some challenges that need to be addressed before they can be widely adopted. These were the references I used here.